Hello everyone, I am Gobikanan. Welcome to our maths class. Today we have see this chapter 3 matrices, exercise 3.4, question number 11. Find the inverse of each of the matrices if it exists. So the given problem is 2 minus 6, 1 minus 2. First we rewrite the matrix given in the format A, which is equal to I into A. And applying elementary operations on A equal to IA, we get I equal to BA. Then B is called an inverse of the matrix. This is the procedure. Now we apply the procedure solution. We rewrite the matrix in this form. First we have considered A, which is equal to 2 minus 6, 1 minus 2. Then we rewrite the form A equal to IA. Okay. So 2 minus 6, 1 minus 2, which is equal to I, identity matrix. So for order 2, 1, 0, 0, 1. Then we write A simply. Okay. Now you can apply the sequence of row operation. This left hand side we convert the identity matrix. So the identity matrix rule is the first entry is the 1. So we see this the second entry. So we have interchanging these two rows we get. So we apply R1 interchange R2. 1 minus 2, 2 minus 6. Then apply the same procedure also here 0 1 1 0 into A. Now the identity rule is the second entry is 0, so we multiply by 2 and subtract these two rows. So the operation is R2 implies R2 minus 2R1. We can apply that is this. We multiply by minus 2 in this first row, we get minus 2, and minus 2 into minus 2, 4. Here 0, here minus 2. Then sum of these two entries, we get minus 2 plus 2, 0. The first row there is no changes, so we write 1 minus 2 and 4 minus 6 minus 2, which is equal to 0 plus 1, 1, and minus 2 plus 0, minus 2. The first row is 0, 1 into A. Okay, next this entry should be converted to 0, so we get just subtract these two rows again, we get, so R1 implies R1 minus R2. Then we get 1 minus 0, we get 1, minus 2 minus of minus 2, we get 0. Second row there is no changes, 0 minus 2, which is equal to 0 minus 1 minus 1, and 1 minus of minus 2, we get 1 plus 2 and 3. Okay, so the second row 1 minus 2 into A. And identity rule, the condition is this entry converted to 1. When we get, we can divide it by minus 2. Okay, so we can write the answer in second row. So R2 implies minus 1 by 2 into R2. The first row there is no changes, so we write 1 0. Second row 0 into minus 1 by 2, 0, minus 1 into minus plus 2 by 2, 1. So we get the first row minus 1 3, and this row minus 1 by 2 and minus 1 by 2 into minus 2, we get 1 into A. So this is an inverse of the matrix. Therefore A inverse, which is equal to minus 1 3 minus 1 by 2 1. Next, sum number 12, 6 minus 3 minus 2 1. So let A equal to this matrix. Now we rewrite the form A equal to I into A. This is the format. So we write 6 minus 3 minus 2 1, which is equal to identity matrix for order 2 is 1 0 0 1 into A. Now we convert this left hand side in identity matrix. So this the first entry is 6. So you can divide it by 6. We get this entry is 1. Okay. Now applying the rule, R1 implies 1 by 6 into R1. Now we get, so 1. And here minus 3 by 6. So we get minus 1 by 2. Second entry there is no changes. Minus 2, 1 equal to, and the first row we apply the operation 1 by 6 into R1. So we get 1 into 1 by 6, 1 by 6, and 0 into anything, 0. 0, 1 into A. Next we convert this entries 0. Then we apply 2 into R1 and plus R2. So the rule is R2 implies R2 plus 2R1, because there are both are opposite signs. So we just add this answer and we get the first entry row is there is no changes, 1 minus 1 by 2. The second row we can change 2R1. So 2 minus 2, 0. And 2 into minus 1 by 2, minus 1 plus 1, 0. And which is equal to, first row there is no changes, 1 by 6, 0. And here now apply 2 R1. 2 into 1 by 6, we get 1 by 3. And 2 is 0, 0. So 1 plus 0, 1. We get A. Here we note this. All the zeros in the second row of the matrix in the left hand side. So the inverse does not exist. A inverse does not exist. Next, sum number 13. We take the matrix A, which is equal to, okay, since A equal to I into A, we write this form. Therefore, the A matrix is 2 minus 3 minus 1, 2, which is equal to identity matrix is 1 0 0 1 into A. The rule is we converted this left hand side matrix is identity matrix. So the first entry we converted to 1. So we divided by 2 in the first row we get. So we write the procedure, R1 implies 1 by 2 R1. Then we get 1 minus 3 by 2. The second row there is no changes, minus 1 and 2, which is equal to 1 by 2, 0, 0, 1 into A. Or we can say this is, we get this term is fractional. So we easily converted to this entries 1. We can say this. Just we have adding these two rows or another form. That is R1 implies R1 plus R2. We can say this. So 2 minus 1, 1. And minus 3 plus 2, minus 1. So second row, minus 1, 2. Which is equal to 1 plus 0, 1. 0 plus 1, 1. So second row, 0, 1 into A. We apply both rule. So now I consider this one. Next, this entry converted to 0. So you are just adding these two rows. That is R2 implies R1 plus R2 or R2 plus R1. We write both formats. So the first row 1 minus 1. Second row minus 1 plus 1, 0. 2 minus 1, we get 1. Now we can get 1 plus 0, 1. 1 plus 1, 2 into A. Now the final format is the entry should convert it to 0. Just we have adding these two rows. Again we apply the same procedure, R1 plus R2. But the resultant matrix we write in the first row. Okay. We get 1 plus 0, 1. Minus 1 plus 1, 0. Second row no changes, 0, 1. Which is equal to 1 plus 1, 2. 1 plus 2, 3. And 1, 2. So this is your answer, A inverse, which is equal to 2, 3, 1, 2. So sum number 14. Let's consider the matrix A equal to 2, 1, 4, 2. And we write the form is A equal to I into A. So A matrix is 2, 1, 4, 2. Which is equal to the identity matrix 1 0 0 1 into A. we know the procedure applying sequence of elementary row operation and our column operation. Anything have to. So the entry converted to 1. So we write the form R1 implies 1 by 2 into R1. We get 1 by 2. And the second row 4, 2, which is equal to 1 by 2, 0, 0, 1 into A. Next we have see the entries 4. So we convert to 0. Then we apply R2 implies R2 minus 4R1. Okay. So first row there is no changes. 1 by 2. Now applying minus 4 plus 4 0. Here multiply by minus 4 we get minus 2 plus 2 0 again, which is equal to multiply by minus 4. So we get minus 2 plus 0, minus 2, and 0 plus 1, 1. The first row 1 by 2, 0 into A. Since the left hand side of the matrix, the second row fully 0, there is no non-zero entry. Therefore, A inverse does not exist in this problem. Does not exist. We conclude this. Okay. I hope we are understand this method. So please cooperate my channel. If you have any suggestion, please comment on the comment box and share to your friends and relatives, and don't forget to subscribe. Okay. Thank you to all.